In the third video concerned with boosting your digitalization, I want to talk about the architecture capability area. This is important because digitalization changes the way in which we develop and deploy products. As I've indicated in the earlier videos, we're moving towards continuous delivery of value to our customers and to systems in the field. And that causes a situation where we need to adopt DevOps, and DevOps simply changes the way in which we work with R&D and with architecture. The second aspect is traditional companies have had a tendency to allow for customer-specific adaptation or customization, which is prohibitively expensive in a DevOps context because you shouldn't just deploy it once, you have to deploy it again and again and again and again for every individual customization that you've actually performed. And then finally, many companies that I work with are basically quote-unquote flying blind with respect to what features are being used, which features are being prioritized by customers, whether customers do what they actually say that they do. And we basically are in many ways flying blind. And the notion in digitalization is that once we have DevOps and we have a fast feedback loop, we can actually now use the data that we have access to and make much more informed decisions about R&D. So if we talk about the architecture dimensions, I want to talk about three dimensions: Superset platform that we'll talk about, modularization, and instrumentation. If we talk about the Superset platform, this means that rather than having development for each and every individual product or customer-specific deployment that I'm creating, I basically have one single code base, and out of this, and in the single code base is the superset of all the functionality that all our products in our portfolio are actually providing. And out of this single code base is every product fully automatically derived using a product configuration file of some kind. Every time that this happens, a product is derived, we also kick off automatically the continuous integration and test environment in order to make sure that all the products that are derived from the single code base are still at production quality. All the agile teams that we have available are all contributing their code into the single code base, and these teams can be working on new features, new functionality. They can work on the defects that have been identified, or they can work on refactoring and the runway backlog, which maybe typically is driven by the architect team. But what is important is that rather than having a basic platform where I build customer-specific or product-specific things on top of, now we're moving towards a single code base, a superset platform, where every product is basically a subset of what is being held in the single code base. The second is that traditionally, especially embedded systems companies have allowed for very rich and strong interdependencies between different components and subsystems. And the reason for this is that it very often allowed them to minimize the amount of bill of materials because they could run more of the functionality on lower cost hardware. That is no longer an option in the case of DevOps. What we have to do instead is we need to minimize the interdependencies to the point that we can allow independent updating of individual components to minimize or even avoid downtime of systems, especially when we do bi-weekly updates, or in some cases even more often updates. We cannot have a situation where the system has to be taken down all the time. We want to minimize and if possible even avoid downtime altogether. Finally, in order to facilitate this independent updating, this is where containers and message buses are very effective decoupling mechanisms. So where feasible, use those to minimize internal dependencies or interdependencies. Finally, instrumentation. As we are adopting DevOps, we do not only have the superset platform approach that I described earlier, we also get our software out to systems in the field on a continuous basis. And what we need to do is to make use of the data that we can now collect from these systems in the field. They are clearly connected, otherwise we couldn't deploy software in them. And then we can use this data and process it, apply analytics to it, apply labeling to it, so we can actually get additional information about how the system is actually performed in practice. And we can do that through A/B testing. We can do that by getting performance data. We can measure user behavior. We can use the data for training machine learning or deep learning models. But basically, we need instrumentation in place to a much larger extent, not focused on quality assurance only, but much more on measuring whether we are delivering the value to customers that we actually can. And instrumentation has to be an integral part of what we do in technology and in architecture. So concluding, DevOps is a logical consequence of digitalization because we want to move to continuous value delivery. So that requires us to adopt a superset platform approach because it becomes prohibitively expensive to do customizations every 2 to 4 weeks for every customer-specific version of our software that we have ever created in the past. The final thing is that because we have now data coming back from the field, it allows us for much more informed decision making, and we really need to make use of that opportunity. And with that, I would like to thank you for listening to the architecture dimension, and I look forward to seeing you in the next video.